Hello. In my previous video, I've shown you the binary search algorithm. Unfortunately, the binary search algorithm that I've presented has a small problem. If our array is extremely huge, we're going to have an integer overflow here. What does that mean? The largest array value in Java is something close to the max integer value. I think currently is actually, funny enough, max integer -5 via to some implementation details. So what happens here if in this step when we add start and end, and if there happen to be very large values close to maximum integer, when we add them together, they may actually exceed that value, and we're going to have a negative value here, resulting obviously in index out of bound. So first of all, since I'm making these claims here, let's test that. So let's create something called big array. So that will be the new int, and let's start with this integer max value. Sorry, it's all capital. And let's just see if we can run the program now. First of all, does that even work? Requested array size exceeds the VM limit. So let's go with the actual maximum, which I believe to be -5. Let's try that. And then we run out of Java heap space. Okay, so obviously we need to increase the memory. And to do that, we need to change the run configuration. So we're going to provide an option here to give ourselves 13 gigabytes of memory in order to allocate this array. I know it's 13 gigabytes thanks to trial and error simply. So let's run that now. And it takes a while, but we get here. Okay, so that actually runs correctly. So let's allocate a couple values here. Let's go with this integer max value -6 equals 2, and -7 equals 1. So what that basically will do is that our array will be full of zeros ending with 1 and 2. Let's try now this binary search on our big array, and let's look for number 1. Let's see that error happen. And again, it takes a moment to run. Thankfully, I have quite a fast machine, but oh, boom, negative value here. So that's index out of bound. So we need to fix that problem. One way to do it is to do some small rearrangement here, basically to avoid it ever going over the maximum value of the integer. So what we want to end up is half of end value and half of start value positive. So I will take end minus start here. So that definitely cannot go over the integer max value because we're removing values, and then add the start value here in the beginning. So we end up with half an end positive, half a start negative here, and plus full one start positive, which ends up basically in the same expression as we had previously, but without the problem of this being ever during the calculation above that integer max value. You can kind of rearrange it using basic maths here. So did that fix the problem? Let's have a look. Let's try to run this again. And it looks like we get a value. Let's confirm that this is actually the correct answer. We can do that by simply printing out the integer value here and checking if it's the same. And if we did everything correct, it should be. And yes, it is the same, so that's great. That showed us that we fixed the problem, and now we can deal with even with the extremely large arrays here. So I hope you enjoyed this video. If you want to watch more of these algorithmic videos, please subscribe to my channel, and I'll be uploading more soon. Thank you.